Live? Okay. Good afternoon, guys. Good afternoon, all of you. Okay. Okay, so we were discussing electrochemistry in this English session, and we will continue from where we left in the last session. In the last session, I was discussing with you guys about how to represent a cell. We were discussing cell representation. Today we will take some more example of that, and then I will move on for the further topic that is going to be our Nernst equation. Prior to Nernst equation, we will see the difference between standard cell potential and non-standard cell potential also. So in cell representation, I told you about some rule about the positioning of PT, about different type of half cell that we are going to use in electrochemistry. I already discussed it in the previous lecture. If anybody haven't watched that, you guys can watch it after this session. And if somebody is new over here, please do consider subscribing our channel and like the video if you feel so. So today we are going to discuss cell representation, little bit examples. So I will write down a equation, cell equation, and then we will deduce cell representation from that particular equation. So if the examiner asks you to write down cell representation, write cell representation of given cell reaction, how will you write it down? Okay, just wait for a second. Okay, so I already told you guys to subscribe Chem Academy YouTube channel for more such videos, more such sessions. Okay, we will continue with our session now. Write down cell representation for the given cell. If given cell reaction, I will write down the reaction and you have to write down the cell representation. Okay, so if in exam this type of cell reaction is given to you, all of you have to write down cell representation in chat. So how will you write its representation? If this is a cell reaction, how will you write down cell representation for the given cell? Good afternoon, guys. Good afternoon. Good afternoon, Akhilesh. There is a lot of series for JAM also on the channel. You can find them out in playlist. Okay. If anybody want to study this whole electrochemistry in Hindi version, then they can also find that out in the playlist. In marathon playlist, you will find out 2 marathon classes of electrochemistry that covers entirely your syllabus. I will say that, except for electrolytic cell and conductance, that part is not being discussed in those videos. So okay, write down the cell representation. Try yourself. Try to write down the cell representation for the given cell reaction. The cell reaction is when AgI is treated with Cl negative ion. This lead to the formation of AgCl and I negative. Means basically Cl negative is displacing I negative from here. Now okay, Ag positive, Cl negative, I negative. No, Akhilesh, this is entirely wrong. This is not correct. So in previous class also I told you about few of the things, that generally chloride or iodide of silver are insoluble salt, and iron are stable in aqueous state. So this much we know from our knowledge of chemistry. Now what we have to do is we have to look at the oxidation state of all the element given in the reaction. Here Ag is present in +1 and I is present in -1. That is not a big deal, you can easily find it out. Similarly here also Ag is present in +1 and Cl is present in -1. Here oxidation state is already mentioned, -1 and -1. So by looking at the cell reaction, you will see that there is no change in oxidation of any element. So you cannot find out which species is getting oxidized, which one is getting reduced. Such type of reaction are generally known as disproportion reaction, And how can we find out cell representation for particularly disproportion reaction? This is very important to note down, that whatever solid salt is given to you, for salt we know one thing, that we use electron drop technique. In last class I also told you about electron drop technique, and these solid salts are generally used in metal insoluble salt anion electrodes. So we know this much idea. What we will do, that we will take the salt on the reactant side and start dropping electron onto the salt till that point where our metal is extracted in zero oxidation state. Till that point where we find our metal in zero oxidation state. Here Ag is in +1 oxidation state in the given salt on the reactant side. So we will drop just one electron. That electron will be captured by Ag positive ion. It will be converted to Ag0. That is again metal. Metal zero oxidation state are generally solid. Now I negative will be liberated from this solid. This is the reaction of electron drop technique. By electron drop we means that AgI is gaining electron, and gain of electron is known as reduction. So this is a reduction reaction, and reduction take place at cathode. We know this much till now. We already have discussed this much chemistry, this much electrochemistry till now. Now in the reaction of cathode, if this is the reaction of cathode, there is formation of Ag solid, and I am unable to see Ag solid in my product at all. I cannot find out Ag solid in my product. So what I will do is, I will take this Ag in zero oxidation state and will react it with Cl negative, my another reactant. This reactant is still not being used, and we know that metal when react with anion generally lead to the formation of an insoluble salt, that is AgCl, with liberation of electron. And if electron is liberated, that means oxidation have taken place. Definitely yes, oxidation have taken place. You can also check out whether it is oxidation or reduction by looking at the oxidation state of the metal. Definitely you can check it out. This is oxidation, and oxidation in electrochemistry take place at anode according to IUPAC. We know this, that this is a reaction of anode. If we combine these two reactions, if I add these two reactions, I will have my cell reaction, and I will again recheck by adding whether this reaction is exactly like the one which is given to me in the question. When I add these two cell reactions, half cell reaction, cathodic and anodic reaction, I can easily figure out that I am again getting the same cell reaction which was given to me in question. So now by this method we can find out anodic and cathodic reaction for disproportion reactions. For disproportion reactions. Remember, you always have to drop electron on solid salt given to you on reactant side. There will be two solid salt, one on reactant side, another one on product side. Product side salt is being formed into this reaction. So we know very well that reaction must have started with the reactants, and we have to drop electron on the reactant. This is a technique by which how we can find out anodic and cathodic reactions, anodic as well as cathodic reaction. So first we will find out cathodic reaction. Whatever the chemical species forming which is not a part of the overall cell reaction, we will take that reactant, we will take this product and we react it with another left reactant. We will have our final cell reaction. If we know these cell reactions, then we can easily write down their representation. So for cathode representation, we know that AgI is being converted into Ag by liberation of Cl negative. This is basically what? This is basically metal insoluble salt anion electrode, and we know very well whenever this is behaving as cathode, we will write anion first, then metal insoluble salt, and then we will write down metal. Anode, how to represent anode? Again, this is a metal insoluble salt anion system. We can figure it out by looking at the reaction. So we will easily represent it also. We will represent it by writing down metal which is getting converted into AgCl. That means oxidation is taking place from 0 to +1 by liberation of Cl negative. So this will be the representation for anode. We have represented anode as well as cathode. Both of these are metal insoluble salt anion electrodes. And we can now write down the cell reaction by simply using rule of ABC. Means on the left side I will represent anode, on the left side I will represent anode, on the right side I will represent cathode, rightmost side I will represent cathode, and in between them I will represent salt bridge. Salt bridge is represented by two parallel lines, two parallel pipes or two parallel lines. By using this rule I can easily represent this cell now. We know the representation of anode. What is the representation of anode? That Ag is getting converted into AgCl by liberation of Cl negative, and AgI is getting converted into Ag by liberation of I negative. So this will be my cell representation. Always do remember that for these type of reaction, these disproportion reaction, all you have to do is you have to take the salt on the reactant side and drop electron till the metal is converted into zero oxidation state. Use that metal for finding the another reaction. That is very simple. This is very simple method of finding out what is anode and what is cathode in a disproportion reaction. Which species going oxidation, undergoing oxidation, which species going undergoing reduction. Easy. I will give you another question. I will give you now another question. Have a look at this question also. Write down cell representation for given cell reaction. Cell reaction given to me is FeOH whole thrice solid forming Fe3 positive. Now ion are stable in aqueous state plus 3OH negative. If this is my cell reaction, write down the cell representation. Do try it, then I will tell you the solution. This is very similar to the previous example. Screen over. This one is very similar to the previous reaction. Very similar to the previous reaction. Try it out. Okay. Vinayak Patil, there is all the lectures available on YouTube, particularly in English as well as in Hindi version also. For Hindi you have two marathon classes. These are two marathon classes for Hindi. Whereas in English we are continuing the series. This is, I guess, this one is 6th or 7th lecture. So you have all the lectures in English also. Previous lecture you can go and watch them. There is no issues in those lecture. You can easily find out that what we have discussed so far till now, what we have discussed. Sir, बिल्कुल, definitely we will ask about it, Gaurav. Definitely. Yes, chapter wise there is playlist on the channel. You will find every topic chapter wise, not even electrochemistry, all topics you can find them out in the playlist. You just have to surf a little bit. Good afternoon, Deepak Verma. Okay, so try to write down the cell representation for the given cell. Try to write down the cell representation. How you will solve it? Again, this is a disproportion reaction. First find out the oxidation state. Here F is in +3 and it is still in +3. So you will see no change in the oxidation state. Oxygen is in -2. Here also oxygen is in -2. Hydrogen is in +1 oxidation state. Here also hydrogen is in +1 oxidation state. So by looking at the oxidation state, you will not be able to find out which species is getting oxidized and which one is getting reduced. Thank you, Mahendra Kumar ji. So which species is getting oxidized and which species is getting reduced, you will not be able to find out by simply looking at the oxidation state. How you will solve this type of question, I have already told you in the previous example. Again, we will repeat the steps. First, we will take the insoluble salt. on the reactant side and we will drop electrons, that many electrons which will be responsible for converting this ion into zero oxidation state. So I will use 3 electrons this time, and this will convert my Fe+3 into Fe zero oxidation state, and metal in zero oxidation state are solid, as well as it will liberate 3 OH negative ions. It will liberate 3 OH negative ions. By electron drop technique, I can write down reduction reaction. Gain of electron is known as reduction. Decrease in oxidation number is also known as reduction. So I have written reduction reaction, and reduction in electrochemistry according to IUPAC take place at cathode. So we can easily find out the cathodic reaction by using electron drop technique. By using electron drop technique. We can easily write down this reaction. Right? Electron drop technique. Now we have 3 OH negative as a product. This is also a product of my complete cell reaction. I have used this reactant also. The only species which is extra over here is Fe solid in zero oxidation state. There is no other reactant left. So what I will do, I will take this Fe zero oxidation state solid and try to oxidize it. Till that ion which is my one of the product in given cell reaction. So if I have to oxidize Fe0 to Fe+3, that means Fe will undergo loss of 3 electrons. Definitely it will undergo loss of 3 electrons. And loss of electron are known as, if a species is undergoing loss of electrons, that is known as oxidation. And oxidation in electrochemistry according to IUPAC take place at anode. We know this much. This is the definition of anode basically. So I have written now reduction as well as oxidation reaction. I will again check and confirm whether these 2 reactions are correct or not by adding these 2 reactions. And if on addition I get exactly the reaction which is given to me in the question, that means I have definitely written correct reactions for both anodic as well as cathodic processes. So when we add these 2 reactions, so electrons will be cancelled, Fe solid will be cancelled, we will have FeOH whole thrice getting converted into Fe3 positive plus 3 OH negative. Now during this process I have found the reaction for reduction and oxidation. That means I have anodic and cathodic reaction. So we will separately represent them. We will represent cathode, we will represent anode. How we will represent cathode? So cathodic representation is very easy. We are seeing a insoluble salt. We can easily see a metal and an ion that is a part of insoluble salt. So this is basically metal insoluble salt anion electrode. And for these type of electrode, cathodic representation is very, very simple. We just write down FeOH whole thrice, which is getting converted into Fe by liberating OH negative. Do remember, we do not show these stoichiometric ratios in cell representation at all. We do not represent electron in cell representations at all. Now for cathodic reaction, we have already represented the cell. What about anodic? Anodic representation, this is very simple. We are just seeing a metal and metal ion. That means this is a metal ion electrode. And for metal ion electrode, representation is very simple. We will just write down Fe from 0 is going into Fe+3. That's it. We will use a pipe to show a state change. It is a state change from solid to ion. That means aqueous form. We will easily represent it. Now I have representation for anode as well as cathode. I can easily write down the cell representation by using the rule of ABC. This is very easy. I will first represent my anode, which is Fe, changing into Fe+3, then using a salt bridge, then I will write negative, then I will write down FeOH whole thrice solid, and later I will represent Fe. This is the cell representation for the given cell reaction. Good afternoon, Charamveer. Is it oxidation? Yes, this later reaction is for oxidation. Lower one, this is for oxidation. Yeah, loss of electron is known as oxidation, right? Loss of electron is known as oxidation. So this is the cell representation. In some books or in some examination, the examiner may write this representation in little bit different form. Here Fe is solid, Fe3 positive is aqueous, and OH ions. Ions are always aqueous in electrochemistry because ions are more stable in their aqueous state rather than in solid or gaseous state. You will never find ion in solid or gaseous state. You will just find them in aqueous state. And these two pipes, these two parallel pipes, this represents my bridge. This represents my bridge. Sometime examiner may also write the exact same representation in following manner. Have a look at it. They will write Fe solid, then they will write FeOH whole thrice aqueous. What does this aqueous mean? Then they will again use a pipe and write down FeOH whole thrice solid, and then again Fe, then again Fe solid. Now you will be a little bit confused over here that there is no salt bridge representation. There is no salt bridge representation. What is the key difference between these two representations? These are very much similar. These two representations are very much similar. To note down the difference is that in first representation, the examiner have represented salt bridge. That essentially means these two electrodes are set up in different beakers. Different beakers means one anodic beaker is separated by cathodic beaker. They are not in contact with each other. That is why we are using a salt bridge, so that my solutions stay neutral during the cell process. If the solution are not neutral, that generally means my cell will stop working. We have already discussed it in the past. What does second representation mean? Second representation means that anodic and cathodic compartment are not separate. They are just separated by a semi-permeable membrane. They are not using, my examiner or the exam paper setter is not considering that these two electrodes are set up in separate beaker. Instead, it is saying, this representation is saying that this is in same beaker. Whole setup is in same beaker. The only difference is that here they are using semi-permeable membrane. Semi-permeable membrane generally allows ions to transfer from one part of the solution to another part. Whenever there is a potential gradient, means whenever Fe3 ions are more in number in one side of the solution and other side contains more number of OH negative, so there will be a potential gradient. There will be two separate charge in the same solution. So SPM will allow these ions to diffuse through it, to travel through it and neutralize. Means here neutralization is taking place by movement of ions in the solutions. Ions are moving. Whereas in first representation, there is no movement of ion. We are using salt bridge. I will draw these two and that will clarify it more to you. So according to the first representation, that means we have Fe plus 3, and then we have a salt bridge. Then there is OH negative, FeOH whole thrice solid, and there is a Fe. So this representation means that I have two separate compartments, as I already told you. First compartment or the left side compartment generally show oxidation half. Now this oxidation half contains a solution where Fe3 positive ion is present in contact with a solid rod of Fe. In contact with a solid rod of Fe. This representation means this one. And cathodic representation means that we have a beaker where there is presence of OH negative ions in contact with a electrode which have a paste of solid FeOH whole thrice. FeOH whole thrice. FeOH whole thrice paste is present on Fe electrode, and this is dipped into a solution where there is presence of OH negative ions. These two beakers are now joined by an external circuit, an external wire, and to neutralize the solution we are using a salt bridge. Which will neutralize both these solutions. Whereas second representation, which I just showed you in the previous slide, that is second representation. Sometime examiner may give you this type of representation also. You don't have to confuse in them. This just simply means that whole cell is set up in same beaker. Now if examiner mention FeFeOH whole thrice aqueous, then write down FeOH whole thrice solid and again Fe. This generally means that whole cell is set up in a single beaker, where one side of the beaker contains Fe electrode, solid iron Fe electrode, and another side contains a solid Fe electrode which is having a solid paste of FeOH whole thrice on it, a solid paste of FeOH whole thrice on it, and this whole electrode is dipped into a solution which is having two ions. Which two ions? There is presence of Fe plus 3 ions and there is presence of OH negative ions due to FeOH whole thrice. Now these two compartments are separated by a semi-permeable membrane. Here we are not using any salt bridge. And if there is presence of semi-permeable membrane, if there is presence of SPM, this generally means that when oxidation will take place, Fe3 ions will be formed on this side, whereas when reduction will take place here, there will be formation of OH negative ions. If you don't know how ions are formed in metal insoluble salt and ion electrode, please consider it. Go and watch the previous video. There is detailed explanation of all these phenomena, how ions are being formed on anodic side, how ions are being formed on cathodic side. So as the concentration of Fe3 positive on left side increases and OH negative on right side increases, there will be generation of positive and negative charge in the same solution which is separated by SPM, and this SPM will allow diffusion of ions through it so that the solution become neutral. So my purpose of salt bridge was to neutralize these two solutions also. Here also Fe3 was forming, OH negative was forming, but salt bridge anion and cation, what they were doing, that anionic part of the salt bridge was traveling towards the container which is containing Fe3 positive ion, whereas cationic part of salt bridge electrolyte was traveling towards the solution which was containing OH negative ions. So this is the key difference. And nothing else. There is no other difference in these two cell representation. Do not get confused by these two. Akhilesh Yadav, why we are not using salt bridge? The reason for this is that there is no need of salt bridge. What is the use of salt bridge? I have already discussed in various classes now, in English version also as well as in Hindi version. The only use of salt bridge is to neutralize these two solutions. When there is charge, the cell working stops because electron and this ion start having electrostatic interaction. Electrons and this ion have electrostatic repulsion. One half have attraction, another half have repulsion. So due to this attraction and repulsion, this electron flow stops. That is why we use salt bridge. Here in this particular type of fashion where we are using SPM, these ions will be diffused. So they will always neutralize each other. Their movement will neutralize each other. That is why we do not require any salt bridge in this particular type of setup. So that's the only key difference. Here you will not see a cell with salt bridge, but if there is a use of salt bridge, examiner will give you this type of representation. If examiner have given you second representation, just to solve, now you know the meaning of these two representation. To solve this particular cell, to find out the cell reaction, what is anodic half, what is cathodic half, what you have to do is, whichever part is aqueous, try to break it into ions. When you break it into ions, you will see that there is a metal which is in contact with its ion, and there is a metal as well as metal insoluble salt in contact with its anion. Now just write down this representation in this manner. You will easily see anodic and cathodic half, and now you can write down the cell reaction. So this is a way of solving this. This is a way of solving this particular problem. If you encounter such problem, this is the way you will solve this particular problem. There is no key difference. The only difference is that salt bridge is missing. These ions are getting diffused. So you have to picturize it in your mind. These two differences, right? These two type of representation, these two type of cell you have to picturize. This is very important, particularly when we will reach concentration cell. Whenever we will reach concentration cell on YouTube, you will find out that we will be using this type of cell very often. Quite often we will be using this type of cell. There we will not use salt bridge because we will see that when concentration cell with LJP, this type of cell contains liquid junction potentials. Liquid junction potentials. Whether they are concentration cell or not, they always contain liquid junction potential. Whenever there is a use of SPM, there will be formation of liquid junction potential. At this junction, one half of the solution is positive, another is negative. So there is a potential gradient, there is a potential difference. So that potential difference is known as liquid junction potential, where these two halves are meeting through SPM. So that is one key thing that you have to remember, right? That is one key thing that you have to remember. Okay, we will now move forward. I will write down a cell representation and you have to write down the cell reaction. Write down the cell reaction. Write down the cell reaction for given representation. Given representation. In previous two examples, I gave you cell reaction, then I asked you cell representation. Here I am giving you cell representation. You have to write down the cell reaction. So cell representation, I will write down the cell representation. We have FeOH whole thrice solid. I have written over here. This one is also solid. Look at this solid and aqueous marking carefully, because you have to break that particular system which is aqueous. Solid never forms separate ions. Solid means ions are in great contact of each other. They are held up tightly together, so they will not flow, they will not form ions. Wherever aqueous is written, that means that this particular salt is dissolved in water, and whenever a salt is dissolved in water, there is formation of ions. Do remember this. We have FeOH whole thrice aqueous and then another electrode, that is Fe. Try to write down the cell reaction for this given representation. Try to write it down on your own. We'll give you some time, 1 to 2 minutes. Try to write it down. First step will be, you have to break this aqueous system into ions. Then you will see a cation and anion. You just have to match cation towards that side which is having a metal, and anion to that side which is having a metal insoluble salt. You will have two halves clearly seen to you. One will be left side, one will be anodic, right side one will be cathodic half. Write down the anodic and cathodic reaction, add those two reaction, and you will see cell reaction. Just this much you have to do. Just this much you have to do. Try to write down the cell reaction on your own and type it into the comment box. Let us have a healthy discussion right here. I hope, Akhilesh ji, it is clear to you. Now I hope your question is clear. Okay, Tulip, thank you. Okay ji, okay ji, thank you. Your thank you have been received. Try to write down the cell reaction fast, as soon as possible. As soon as possible. Try to write down the cell reaction fast, as soon as possible. Then I will solve it. Then I will solve it. Okay. Let me just break this particular system into ions. I will break this particular system into ions. That this particular system consists of Fe+3 and OH negative ions. So here there is metal electrode. Here there is metal insoluble salt. So we know metal insoluble salt, and anion must be there for saturation. For saturation, we use this anion for this particular salt to get saturated and remain in solid state. I told you this in previous class. So I will write it down. I will write it down in the manner with which we are very much familiar. I will first write down Fe, then write down its insoluble salt, and with insoluble salt there is always an ionic part. So this is one part. Then I will write down a salt bridge, imaginary salt bridge from my own side for the sake of solving the problem. then I will write down Fe plus 3 ions in contact with Fe. By doing so, I will clearly see my anodic half. This one is anode over here, this is anode over here, and this half is my cathode. This is my cathode. So on anode we know oxidation take place. So what is anodic reaction? Now I can write it. Oxidation of metal insoluble salt anion that generally occur when a metal is attacked by its anion. When a metal is attacked by its anion, it will form insoluble salt and will liberate electrons. How many electrons will it liberate? It will liberate the electrons that is equivalent to the oxidation state of Fe0 to Fe plus 3, which is the oxidation state of Fe in this particular salt. So this is solid, this is aqueous, this is again solid. How we represent this particular type? We easily represent this by Fe OH whole thrice, and then there is a presence of OH negative. So by representation I can write down reaction, by reaction I can write down representation. Here representation is given. So cathodic part, what is cathodic part? Cathodic part consists of Fe and Fe3 positive. So on cathode there occurs reduction. So I can easily write down the cathodic reaction also. Reduction is simple phenomena where a system in higher oxidation state goes to its lower oxidation state by gaining electrons. So this will be my anodic and cathodic reaction. I have to find out the cell reaction, that is what question demands from me. So to write down cell reaction, there is only simple one last step left, that is I have to add these anodic and cathodic reactions. When I add these reactions, I can easily find out the overall cell reaction. On adding these reaction, I can easily find out the overall cell reaction. Cancel these electrons, cancel the common part, you will easily find out the overall cell reaction of Fe plus 3 attacked by 3 OH negative, leading to the formation of FeOH whole thrice. FeOH whole thrice. This will be my cell reaction. This will be my cell reaction. Now have a look at these two slides simultaneously. This particular one, this slide, and the one before it, In previous slide, the representation was Fe, aqueous ion, FeOH whole thrice solid, and then there is another Fe solid. So here we said that Fe3 positive metal ion system was the anode, and cathode was metal insoluble salt anionic system, and cathode was metal insoluble salt cation anionic system. Here it is reversed. Here what we are saying is that metal insoluble salt anion is our anode, and cathode is basically having metal ion system, I hope it is clear to you now. So by looking at reaction, now you can find out cell representation. By looking at representation, you can find out cell reactions also. So this is one of the key important aspect area of electrochemistry. To understand the questions which will be given to you in your competitive examination, you need this type of knowledge. This is very, very important. Sometimes direct question also comes from here. GATE asked this type of question, write down the cell representation or cell reaction of the given representation. This type of question generally is asked by GATE examination. So for GATE examination, one of your key important topic is discussed over here. Another important aspect of this particular topic is that in entire electrochemistry, whichever question is given to you, you have to find out these reactions. How electrode potential changes in case of metal ion half cell and metal insoluble salt anion half cell of same element. This is being asked by chemistry by Sandeep Singh. If we have entirely one key important aspect over here is that these two are not entirely same chemical system. Another important aspect is if we have same chemical entities on anode and cathode, then the potential depends on various aspects also, that we will discuss in Nernst just after this topic, most probably in next lecture. Nernst said that electrode potential not only depend on the nature of the element or chemical species, it also depend on temperature, it also depend on pressure, it also depends on concentration. So if the both half are entirely same chemically, still there will be a potential gradient if concentrations are different, or temperature is set differently, or pressure of the two system are set differently. That is being discussed by nurse. Till now we are only discussing standard potential. In upcoming lecture I will discuss it with you, how standard potential is different from non-standard one, which was discussed by Nernst, by his Nernst equation, very famous Nernst equation. So there will be a potential gradient, there is no issue in this. And this one is hypothetical, that this particular example which I give you, previous one and this one I just try to show you that what do you mean by this type of representation, how the positioning of aqueous system will define which one is cathode, which one is anode, so that you can apply that in your examination. What is anode, what is cathode, that will entirely depend upon E node. Whichever system is having more E node, more reduction potential, that species will be our cathodic part. Whichever species having less E node, that will be our anodic part. We have already discussed it, chemistry by Sandeep Singh ji. So if you want to read it in detail, I am again and again repeating that please go and watch previous lecture. We have discussed very little details also in these sessions. This will be helpful to you. If you want to read it in Hindi, you can also watch it in our marathon classes. There is a playlist on YouTube channel, Chem Academy YouTube channel, and there you will find the marathon classes. There you can read the whole entire subject with each and every single detail in Hindi also. So but those videos will be a little longer, right? So now one more important area, one more important question that I will discuss. Write down the cell representation. Write down cell representation. Cell representation of given reaction. Till now I have discussed with you the complete cell reaction is given. Now I will give you a half cell reaction, only a half cell reaction, and you have to find out the cell representation for this particular half cell only. So I will write down a reaction, arbitrary reaction. So if we have such system, 4 OH negative ions getting converted into 2 H2O plus O2 plus 4 electrons. Now this is a half cell reaction. How I identify half cell or full cell? If we have presence of electrons, generally we means that it is a half cell reaction. Standard potential only. I am asking what standard. If you are asking about standard potential, so these two are not entirely same chemical species. Here the reduction and oxidation of solid part take place in insoluble salts. Here in particularly in metal and metal ion system, the ion is in directly contact with the metal. So whenever we change the chemical environment, the potential does changes. The potential standard as well as non-standard potential, both potentials changes. This is not chemically entirely same. If you want to discuss it in more detail, I have already discussed in previous lecture, as I told you, Sandeep. So you can watch this video also. Write down the cell reaction for the cell representation for the given reaction. This is a question for rest of the people watching the video right now. Write down the cell representation. How can you write down the cell representation? So if you want to write down such cell representation, you need to have basic idea. One basic idea is that OH negative is aqueous. Definitely it is aqueous. Water is water, so it doesn't mean that it is basically more stable in its liquid state. So O2 is generally a gas. I have also specified their states now. Try to write down the cell reaction. Yeah, metal, that is what I am saying, Sandeep. It is not chemically entirely same. Their ions are getting oxidized and reduced. Here the solid part, the solid system, which is already in an equilibrium with its anionic part, it is in saturation with its anion, that is getting oxidized or reduced. So reduction of solid and liquid are entirely different things, and that thing make a difference in their standard potentials. Okay. Okay, write down the cell representation for this given reaction, for this particular reaction. Try to write down the cell representation. First, try to find out which species is getting oxidized and which one is getting reduced. Here we have 4 oxygen atoms in -2 oxidation state. H hydrogen is in +1 oxidation state. All 4 hydrogen are in +1 oxidation state. On the product side, all 4 hydrogens are in +1 oxidation state. This oxygen this 2 oxygen is in -2 oxidation state, 2 oxygen atoms. These 2 oxygen atoms are in 0 oxidation state. That means there is a change of 2 oxygen atom from -2 to 0. -2 to 0. What do you mean by this reaction? This reaction is basically increase in oxidation number. So this is a oxidation reaction. So this is a oxidation reaction, and this reaction involves a gas. That means we have to use PT electrode. Definitely we have to use PT electrode. Whenever PT comes into the picture, position of PT will tell us whether oxidation or reduction is taking place. According to IUPAC, we know that left side, leftmost PT means there is oxidation. Beside PT we always represent gas, we know this. We never represent water in cell representation. I have already told you this rule. We never represent electrons, we never represent the stoichiometric ratio. So what is left to represent is this anion. So I will represent the anionic part, and this will be my representation for the given half cell reaction. For the given half cell reaction. So by looking at this particular system, I think now enough example I have discussed with you, including previous as well as this lecture, that you will not face much difficulties in expressing cell representation if a reaction is given to you, or in writing a reaction if a representation is given to you. In writing a reaction if a representation is given to you. So this was our representation part. In next lecture I will discuss with you how potentials changes with temperature, how they change with your concentration or pressure. If the chemical species are same, can there will be a potential gradient? That question will also be answered. And if you think that these two are entirely different chemical species, they are not. Their state is different. That here aqueous state system are more easy for oxidation, easily available for oxidation and reduction, means their potentials will definitely be different from the one which are in solid state, So state difference, how state difference matter, these all questions will be discussed in the next lecture. We'll see you guys in next lecture definitely. And before that, let me remind you of subscribing our YouTube channel, that is Chem Academy YouTube channel. And if you have already subscribed, please consider pressing the bell icon and select all option from there. After doing so, you will always get notified whenever we come live, and we will be able to interact with you. And such interesting questions, just like Sandeep did ask today, such interesting question will keep coming, and we will discuss these type of things related to electrochemistry or other topic or other aspect of chemistry on this channel daily. In English, you will have a session on 2 p.m. daily at 2 p.m. For book session, there is a fixed timing, that is 4 p.m. Today also 4 p.m. we have another session. Please do come at 4 p.m. also. Thank you for joining. This was the part till representation, cell reaction and representation and type of half cell. In next lecture I will discuss with you guys regarding Nernst equation, chemically different species as well as chemically same species, what is the difference between standard potential and non-standard potential, and how these two systems are different. That we will discuss, definitely we will discuss in next lecture. Thank you very much for joining the lecture.